Hello and welcome to another video in the graph series. A lot of you requested me that I should be teaching in dark mode and I take my feedback very seriously. Thank you so much for sharing your honest feedback with me. So in the next few videos, I'll be teaching in the dark mode and you can let me know in the comments if this is more convenient and better for you. I just want to make everything as easy and as convenient as possible. And I just want you to focus completely on learning, coding, practicing. And one more thing that I wanted to say, a lot of you are watching the videos, but you're not actually writing the code and practicing it yourself. When I teach, although I teach line by line and explain everything in detail, it can happen that when you write the code, you might make some silly mistakes and you need to get used to writing code. You'll also get habitual of that, your speed will be better, you will start thinking of all the edge cases. So make sure after watching the video, you also take your laptop and practice writing the code. It is going to take you hardly 15 to 20 minutes. So please do that. And today's question is very important. You're going to learn some very important concepts. So yes, be regular, be consistent. Before we move ahead, I would just like to take a moment to remind you to be consistent and make sure you do not miss any videos in the graph series. So make sure you subscribe, hit the notification bell icon. You will also stay motivated and you have no idea how much your support will mean to me. There's so much of free content available on the channel. There's HLD, LLD, DSA, Advanced C++, tutorials, mock interviews, and so much more. So if you think I deserve your support, please subscribe, hit the notification bell icon. And there's obviously a bunch of stuff that I cannot do on YouTube, like mock interviews, live interactive classes. So we have educourses.com, we have live courses, self-paced courses with live doubt solving support, which both of them we have mock interviews, and we have a lot planned in LLD, HLD, Advanced C++, DSA, and so much more. You have no idea. So if you want me to be part of your further learning journey process, please check it out. The link is in the description. And now let's continue. This is the question that we'll be looking at today. We are given n cities. So here also n is 3, here also n is 3. And we are given that some are connected, some are not. What does that mean? Here C3 is not connected to 1 or 2, right? If A is directly connected with B and B is directly connected with C, then A and C are indirectly connected. What does that mean? So here we have to understand the difference between directly and indirectly connected, right? Directly connected essentially means that there is a direct edge between those two in very simple terms. So very simple, right? That A to B directly connected, there is an edge. B to C directly connected, there is an edge. So A to C, there is obviously a path, right? A to B and then B to C. They are not directly connected, but indirectly you can reach C from A. So it is reachable, or there is an indirect path, correct? We will also be seeing the diagram, so don't worry at all if it is not clear. We will be looking at the examples. Then it is given that a province is a group of directly or indirectly connected cities. So it's not necessarily directed or indirected connected cities, and no other cities outside of the group. So that means basically if the nodes are reachable within themselves, then they together form a province. That is what it means in a simple way. You're given an n by n matrix, and this matrix is basically 1 if I and j are directly connected. So basically it is the adjacency matrix that is given to us. If I and j have an edge between them, if they are directly connected, then the value is 1, otherwise the value is 0. So this means that we are given an adjacency matrix. So we need to understand these things very carefully, that okay, we are given adjacency matrix. Now here you can see that okay, it is a 3 by 3 matrix, right? What does it actually mean? Let's write it down in a very simple way. So if you see it like this, right, and you should be able to visualize it. I'm actually showing it to you because you should also be able to see it and understand that okay, what does this actually mean? So here there are 3 nodes, right? So this is for the first node, this is for the second node, this is the third node. So first node is connected to itself, so that is 1. It is connected to the second node, which is this, and it is not connected to the third node, right? So it is 1 for itself for the second one, but for the third one it is 0. Similarly, for the second node, it is connected to 1, correct? So this is bidirected graph, right? Because 1 is also connected to 2, 2 is also connected to 1. You can go both the ways. Or undirected graph. Here 2 is connected to itself. Now in adjacency matrix, you can note these small things, that is that node connected to itself. There is no self edge or loop given over here, but it is the same node. So you can say that it is directly connected. So these little things you need to keep in mind, right? Here see 2 is connected to 1, 2 is connected to itself, 2 is not connected to 3, that is why it is 0. 3 is not connected to 1 or 2, that is why it is 0, 0, 1. So I hope you have understood how adjacency matrix looks like. Now we have to find the number of provinces. What does this mean? Total number of provinces. Let's look at the diagram now. Here, if say nodes A and B are directly connected, basically there is an edge between them. They are obviously part of one province. Now suppose there is another edge C. So there is a direct edge between B and C, but still A, B, C are in one province only. They are part of one province. Why? Because A and C are also indirectly connected. So there is a direct edge between A and B. There is a direct edge between B and C. That means A and C are indirectly connected. So A, B, C are in one province. Suppose this is our huge one graph. Now there is another, suppose here D and E, they are connected. Then there is another one over here, F, G. Now this is one province, this is another province, this is another province. So we have to find out the number of provinces like this. So in this case, there are 3 provinces. If any of them were further connected, like suppose this was connected, then there would have been only 2 provinces, correct? Similarly, even if say these 2 were connected, or say for example, these 2 were connected, then also there would have been 2 provinces. Or suppose if this would not have been connected, then there would have been how many provinces? Let's see. So this is one province, this is another province, another province, another province, then there would have been 4 provinces. So like this, we have to see the total number of provinces. Now how would you approach this? So we have already seen traversals till now, right? So what happens in a traversal? Suppose I start traversal from any particular edge. Suppose I start from here. Now from B, I will traverse to A and C, right? They are directly reachable. So all the nodes in that province are directly reachable. So if I do traversal once, starting with any of the nodes in ABC, suppose I start from C also, I will visit B and A, correct? Similarly, if I start from A also, I will visit B and C. So when you start from any node, you will end up visiting all the nodes in that province, correct? So what I can do is basically, if I start from any node, if I start from this and I start visiting all the nodes that are reachable from there and I mark them as visited. So I visited this, I visited this. So now all of them are part of one province. Now when I start visiting from any other node, suppose I start from over here, that means, I did not reach that node in my previous traversal. That means that was not part of this province. So now I will do number of provinces plus plus. So suppose here number of provinces were obviously say 1. Then when I go to another node and I start another DFS traversal, then my number of provinces become 2. So now when I start from here, I will end up visiting this as well. So this has become 2 provinces. Now there are still nodes that are not visited, like for example this one. Now this is not visited, so again we will have to do DFS traversal and increase the number of provinces to 3. But here when I do DFS, I am not visiting any other node because this is the only node. It is not connected to anything else. Similarly, I will say, oh, there is one more node. So now number of provinces will be 1 more. So now the important thing to understand is that whenever you do a traversal, that you start from a particular node and you start visiting the other nodes, you will basically end up visiting all the nodes that are there in that province. So if you have to do one more DFS to visit some more nodes, that means they are part of another province. So we keep adding more number of provinces as we keep visiting more and more nodes, as we keep doing more and more DFS. So every time we have to start a new DFS traversal from any node that is not visited, that means we are increasing the number of provinces. Let's try writing the code for this. First, writing the code in C++. For Java folks, you can go to this timestamp. So here we are given the adjacency matrix, which is called is connected. I obviously first need the number of vertices that are going to be there. So in adjacency matrix, what is the size? It is n by n. So if I just find the number of rows or number of columns, I will know the number of vertices. So if I call that n itself, I will do just is connected dot size, that is the number of rows. So I will get n, that is number of vertices. Now what am I trying to do? I am trying to do DFS over a graph. So what do I need? I obviously need a visited array so that I make sure that I have visited all of these elements, right? As I go through the province, I need to keep marking them as visited so that I know, all these elements in this province are already visited. So I will just keep a vector of Boolean itself, which is basically that each node is visited or not. I'm going to call it visited. The size is n and initially none of them are visited. And I obviously have to return a counter, I have to return an integer. So initially I can call it anything, resultant, answer. I'm just calling it counter, which I'm putting it as 0 initially, and in the end I'll be returning this counter. Now I need to do DFS. In a particular DFS traversal, I'll be visiting some of the nodes. Like suppose if I do traversal over here, I'll be visiting 1 and 2. I wouldn't have visited 3. So I'll have to keep doing the DFS again and again till I visit all the nodes. Now, how will I be sure that I visited all the nodes? So basically, what if I always check that, okay, should I do DFS from this node or not, from this node or not? So how will I do that? I basically write a for loop, I equal to 0, I less than n, I plus plus, and I say that I will try doing DFS over all the nodes, but what will be my condition? That this node has not been visited. If it has been visited, maybe it was visited in the previous traversal. Maybe if I am at I equal to 4, maybe it was visited from I equal to 3. Then I don't need to do the DFS again. But maybe there was a province with only this one node, right? So I need to keep checking for every single node that has it been visited or not. Do I need to do DFS from this node or not? And that is why this for loop is very, very important. A lot of people don't understand that why do we need this for loop. I hope you have understood, because from every single node I need to see that do I need to do a DFS from here. Like for example, here 3 is alone, right? There is no other nodes that are connected to this. So I will need to check that do I need to do DFS from this 3 also or not. So if it is not visited, so if I is not visited, then what am I going to do? I am going to call DFS. What all things do I need to pass in this DFS call? Obviously, I need to pass the adjacency matrix, the current I or the current node that I am at, the visited array, and what else? Obviously, I need to pass n as well. So I will be doing DFS and I will be marking them visited. Do I need to return anything from DFS? No, right? I just need to mark them as visited and I am already passing visited, so that should be enough. But every time I do DFS, I should be incrementing this counter. This counter is basically the number of provinces, is the answer that we are returning, and that is it. If you can do DFS, you should be able to write the rest of the code also, but we will be writing it obviously. But remember, the number of times we do DFS, only that number of times I have to increase the counter. So only if I call DFS, I need to have this. So remember, it should be inside this check, not outside. If you keep adding the number of provinces every time, even if I had already visited, then obviously the answer is going to be n only, right? So these small details, I hope you have understood clearly. Let's try writing the code for DFS now. I'm just removing this. And I don't need to return anything from my DFS call, right? I'm just calling it DFS. You could call it anything. You could call it a helper function. You could call it find circle num helper, anything you want. The first thing I am passing is this adjacency matrix. And then I am passing the current node at which I am at. So I have passed this I, right? So I is my current node. I am calling it current so that it is completely clear that what does it mean. And I need to pass this visited vector. Now, whenever we pass vectors or anything in C++, we always pass it by reference. Keep these things in mind. And I am passing the value of n. Now, what do I need to do? I need to traverse through all the neighbors and mark them also as visited. How do we traverse in an adjacency matrix? In an adjacency matrix, to go through the neighbors, we have to go through the entire row. It is not adjacency list, it is adjacency matrix. So remember, how do we go through an adjacency matrix? The row length itself is n. So we need to go through all the n elements. So another for loop, I'm going to call it I itself, I less than n, I plus plus. Now, which row are we going forward to? So I have to check key if is connected, what is connected? Basically, whatever is the current node. So that is the node that I'm considering, right? So for that current node, is I connected to it or not? So basically, if this is true, that means they're connected. There is a direct edge. So that means it is a direct neighbor. So if there is a direct edge, and what should be the other condition? That if it is not already visited. Now I know that some of you might think that because we are within the same province, do I really need to check this again or not? Now remember that within a province also there can be a cycle, right? Like for example 1, 2, 3, suppose all of them were connected to each other. Now even though they are in the same province, we could be visiting them again and again, we could end up in a forever loop, right? So always in graph this visited check is very, very important. So this shows that is it a direct edge or not, basically are they neighbors or not, current and I is not visited. That means we need to visit I and we need to call DFS from there. So recursively we need to go on and now I will become current. So I am calling this DFS and I am passing the is connected, I am passing I. Now I will become my current. So I has become my current and rest of it will remain same, visited and will remain same. Now very important thing. We are always checking that is it visited or not, but where are we marking it visited, correct? So here I will be marking visited of I as true. And there is this extra n that I have added by mistake. We are done writing the code though. Let's try running it and see. We have passed the test cases. Let's submit it and see. Very good. So we have passed all the test cases, very good, and most of the people will be happy that okay, you were able to solve the question. But I wanted to also think that we have done two kinds of traversals, DFS and BFS. Is it possible to solve this question by BFS or not? Think about it and let me know in the comments, because most of the places you will just see DFS solution and move ahead with it. Do you think BFS is not possible? And if not, then why? Let me know in the comments. And before we move to Java code, let's quickly look at the time and the space complexity. Here we are using adjacency matrix. So obviously the matrix itself is of the size order of V square. But we are going through all the vertices in the adjacency matrix at least once. So it is order of V square time complexity. And now let's get started with Java code. Here we are given an adjacency matrix. What is the size of an adjacency matrix? It is n by n, correct? So the first thing that I need to find is the number of vertices or the number of cities that are given to us, which is n. And how will we get that? Is connected either number of rows or number of columns, correct? So if I copy this is connected and I do length, I will get the number of rows, right? So that is enough. I have the number of cities now. Now what do I have to do? I have to do DFS on a graph. When we do DFS on a graph, basically any DFS or BFS on a graph, we need what? We need a visited array. So if I just keep Boolean visited, and what will be the size of it? Yes, n. So this is my visited array. What else do I need? I need to return an integer. What does this integer represent? It represents a counter, that what are the number of provinces. So what is my counter initially? I can just put it 0, and in the end I'll be returning this. I can call it anything. I can call it res, answer, anything. I'm just calling it counter. Now I need to do DFS. So now the question is that how many times I would have to do DFS? Like over here I would have to do it 2 times, right? If I do from here, I would have already visited. Next time I would have to do for this. Here I would have to do it 3 times, because every node is like a separate province altogether. So how many times would I have to do that? So let's try doing DFS from literally every single node. Now the nodes that I already visited are visited. Maybe I am at node 4 right now and I've already visited it when I was doing DFS from say node 2 or node 3. So it is a possibility that I've already visited it, but I will still have to check, maybe that is a separate province altogether. So what can I do? Maybe if I write a for loop, just stay patient with me, you will understand it. So here what I'm trying to do is I'm trying to call DFS for every single I. Basically for every node I'm going to try doing DFS. But I need to be sure that I have not already visited it. Suppose I start from 1 and I already visited 2, right? I have already included 2 in that province, in the province that I got from 1, right? So I do not need to do the DFS again. So what should be my check? My check should be that if it is not visited. So if I have not visited this I, only then I am going to do the DFS, correct? And in the DFS, what all things do I need to pass? I obviously need to pass my adjacency matrix. So I am passing this is connected. I need to pass the visited, and I need to pass the current node at which I am at, which is I, and I obviously need to pass n. So this is how I'll be doing DFS. But every time I do DFS, I need to do what? I need to increment the counter, the number of provinces. Because every time I have a node which is not visited, that means I'm coming across a new province. So here, if this is visited, it was part of the previous province. I do not need to increase the counter. But if I have a node which is not visited, I need to increase the counter. Note that it will be inside this if condition and not outside. If you put it outside, essentially your counter will become n only, right? That doesn't make sense. You need to increment the counter every time you are doing DFS on a particular node that has not been visited. So here all the nodes, like you will have to do DFS again and again. So here it will be 1, 2 and 3. Here it will be 1 and then 2, like that. And basically this is the main code. We are done with it. We just need to write the DFS code, which I am sure you'll be able to understand very easily. Another point to note over here is, do I need to return anything from DFS? No, right? Because I just need to mark them as visited, and that I'm already doing in the array that I'm passing. So I don't need to return anything. So I'm just going to call it like DFS return type, and I'm calling it DFS. You can call it anything. You can call it helper, you can call it util function, whatever you want to call it, you can call it. I obviously first need to pass this adjacency matrix. I need to pass the Boolean visited array. I now becomes the current node with which I am dealing. So I am calling it current itself for further clarity, and I need to pass n. Now note that we are given an adjacency matrix. How do we go through all the neighbors in adjacency matrix? We have to go through the entire row. It is not adjacency list. So note these small details. Since I have to go through the entire row, my I will go from 0 to n minus 1. and what row am I going forward to? So how do I check that this current node and I are connected or not? So if is connected and what? Current is the node, right? So that is the row that I'm going forward to, and I is the column. So if current and I are directly connected, so basically if they have an edge, basically if they are directly connected, then okay, I can traverse. But I also have to check what, because they can also be cycles in this graph. So I need to make sure that I check this. Now you might be thinking that we are within the same province. Do we really need to check that? Now imagine if all of them were connected to each other, 1, 2, 3. They would be part of one province only. But you would visit 2, then you would visit 3, then again 1, and you would get stuck in a forever loop. So you don't want that. Every time you do DFS, BFS in a graph, make sure you put this check. So this means that they are directly connected. This means that it is not visited. So now I need to call DFS again, and now the things that I pass are going to remain same. The only thing that is going to change is connected and visited is same. The only thing that I need to change is this current. But now what will be the new current? The new current is going to be this I, because we are going to the next recursive call. I is going to be the new current, N is going to remain same. But now there is a very important point that is remaining. So we have checked that is I visited or not, but we have not marked it as visited. Now these are very important things that we cannot miss. So I am marking what? I am marking visited of I as true. And because we are writing code in Java, I need to check that is connected is equal to 1 or not. Now let's try running it and see. So we have passed all the test cases. Let's submit it and see. So very good, we have passed all the test cases. Let's quickly look at the time and the space complexity. The adjacency matrix that is given to us itself is n by n, obviously, and we are going through all the elements at least once. So the time complexity also becomes order of n square or order of v square, where v is the number of vertices, n is the number of cities. Now before you go, I just wanted to think about one thing. Whenever you will see anyone solving this question, number of provinces, they will just do DFS and they will move on. But we have done one more traversal, which is BFS. So do you think we cannot solve this question using BFS? If not, why not? Let me know in the comments. I want you to think about it. I want you to try writing the code yourself and let me know in the comments. Keep giving me your attendance that yeah, you have showed up, and that will motivate me also. This is going to be like the most detailed series you will ever see of graphs. We're going to cover everything in so much detail, like all the concepts will be completely clear, and I'm putting in so much effort. If you think I deserve your support, please do share it with your friends. Please help me reach more people, and do subscribe, hit the notification bell icon. You have no idea how much it will mean to me. As we discussed earlier as well, most people will just be happy that okay, we have solved the question using DFS and they will move ahead. But very important thing over here to realize is that here we just need to visit all the cities that are there in a particular province. It is not necessary that we use DFS. We can use BFS itself. Now you will see very less number of people actually writing the BFS code for this question, and I don't understand why, because you can do it. It might be easier, yes, but you need to be used to writing both DFS and BFS code. So we're going to be doing that in both C++ and Java, and let's get started with C++ first. And yes, you need to get used to writing both C++ and Java code, and you should not think that okay, number of provinces or number of islands, these questions you can do only using DFS. You can do using BFS as well. So here you will see what do I need to change, only that instead of doing DFS, I need to do BFS. And you will see that I have to do actually very less code change, and I am actually reusing a lot of code. So instead of doing DFS, I'll be doing BFS. What do I use for BFS? I use a Q. And here what is my node? My node is an integer itself. I'm going to call it Q itself. And here what is the number of times where I'll be doing BFS? Now that is the number of provinces itself, right? Here I am going to keep calling it for every I that has not been visited. So how many times I am doing BFS? Just like how many ever times I was doing DFS, and every time I will just increment the counter. And in this I will start with I. So I is my first element that I am going to push. Obviously I am going to mark it as visited as well. And now what do I need to do? I need to traverse through the Q. So while Q is not empty, I will be visiting through the cities that are reachable from I, correct? So I need to firstly take out the frontmost element. So I am going to call it front itself, Q.front, and I am going to pop the first element, right? So Q.pop, and now I have the front element. What do I need to do? I need to visit its neighbors. How do I do that? Just like this, just like how I did that. Just now that instead, because I've already used the variable, I will have to rename the variable, and that's it. See here, basically I copy pasted the exact same code, But the only difference is that I need to call it k because I've already used I. So I am putting k equal to 0, k less than n, k plus plus. And here see, if is corrected what? So I have to see from front element, right? I have to see front and then I have to see that the elements around it are connected or not. So instead of this front, I could actually call it current also. So this becomes my current and is connected current to this k, and if k is not visited, then I'm going to mark it as true, and then instead of calling DFS, what do I need to do? I just need to put it into the queue. So queue dot push, and that's it. Okay. And now I can actually comment this out. I'm not using it. I'm just removing the DFS code. So this is the BFS code. By the way, the entire code is present on EduCourses under the free content section. So you can check it out. Everything in DFS, BFS, everything is present. So you can check that out also. Let's try running it and see. So this works. Let's submit it and see. Awesome. And by the way, the time and the space complexity remains same for both DFS and BFS, and you need to be able to write the same code. The difference is that here we are not doing recursion. Here basically we have written an iterative code, and you could be asked in an interview that why don't you write the BFS code, why only DFS? So you need to understand all the possible approaches. And now let's get to Java for the same. Coming to the Java code, again, let me tell you that here you will have to do very little code change because we have already written the DFS code. How many times do we have to do the BFS? Same number of times, right? Instead of just doing the DFS, we will be doing BFS. How many times are we doing it? Every time we come across a new province. How do we do that? Every time we come across a node that has not been visited, we increase the number of provinces, the counter, and then we do BFS. How do we do BFS? We need a queue. Now, what is a queue of the integer? Because node is an integer. I am going to call it queue itself, new linked list. And now I need to start my BFS from which element? From this I itself, right? Because this is my first element. I also need to mark it as visited. And how do I do BFS? I will keep going through the elements that while my queue is not empty, while it is not empty, I will take out the first element. So I can call it current itself. The first element is the current element. So that will be my current element, and I will need to go through the neighbors through that, right? So whatever is the current element, I will take that how queue.remove. So I will have the first element. And now how can I go through the neighbors of this? I basically can just copy paste this entire code. Just note that I have already used the variable I, so I'll have to just rename the I. So I'm just writing it properly. So instead of I, let's just call it k. So all the elements k equal to 0 and k less than n. K plus plus is connected. So current is connected to k, and if k is not visited, then visited of k will be true. And instead of calling DFS, what do I need to do? I just need to add it to the queue again. What am I adding? I am adding k. So this is it. We are actually done with the code, and now I don't need this. I can actually remove DFS code, and let's try running it and see if it works or not. Let's submit it and see. Great. So the time and the space complexity remains same for both BFS and DFS. I hope you have understood that you can use BFS as well. And I hope you're liking the series and you're liking all the hard work that I'm putting in. If you appreciate that, please do consider subscribing. You have no idea how much it would mean to me. Please do share it with your friends if you think these videos deserve to be reached, and if you think I deserve the views on the channel, if you think it deserves to go, please do subscribe, share it with your friends. Please hit the notification bell icon, and all the code, by the way, in both C++, Java, it is present on EduCourses. You can go to the free content section and you can check it out. And see you next time. Bye.